Ever wondered how an electric motor works and what challenges engineers face while designing it? Let's start with the basics. An electric motor primarily consists of two parts: the stator, which is stationary, and the armature, which rotates. The armature is where the magic happens. Now here's where it gets interesting. When a current passes through the armature windings, it doesn't just sit there, it creates its own magnetic field. This is known as the armature reaction. This armature-produced magnetic field then dances with the main magnetic field generated by the stator. It's a delicate ballet with each field affecting the other. The armature reaction can cause demagnetization, reducing the overall magnetic flux, and can also distort the main magnetic field. These interactions are essential to understand, as they impact the design and functioning of the motor. Understanding armature reaction is crucial to the design and operation of an electric motor. Now you might be thinking, what effects can armature reaction cause in a motor? Well, let's delve into that. Firstly, armature reaction can lead to something called demagnetization. In simpler terms, the magnetic field produced by the armature current can weaken the main magnetic field of the motor. This reduction in magnetic flux can impact the motor's performance, potentially causing it to run less efficiently. Imagine running a marathon with one shoe untied. You could still run, but it would be far from a smooth journey. That's how a motor can feel when the magnetic field is weakened due to demagnetization. The second effect is the distortion of the main magnetic field. The interaction between the armature's magnetic field and the stator's magnetic field can shift or cause an asymmetry in the main magnetic field. This distortion can affect the balance of the motor, making it less stable. Picture trying to balance a spinning top on a wobbly table. It's quite a task, isn't it? That's the kind of challenge a motor might face when its magnetic field is distorted due to armature reaction. But it doesn't stop there. These effects can also influence the motor's efficiency. A motor running with a weakened or distorted magnetic field may need to draw more current to deliver the same amount of power, leading to increased energy consumption. It's like driving a car with low tire pressure. You'll burn more fuel to travel the same distance. These effects can also cause an increase in the motor's operating temperature, potentially leading to overheating and premature wear and tear. It's akin to running your laptop for long hours without giving it a break. Sooner or later, it's going to heat up, and its performance will take a hit. The effects of armature reaction can significantly alter a motor's performance if not properly managed. And that's why understanding armature reaction and its effects is so crucial in the world of electric motors. Up next, we'll discuss how engineers manage these effects to ensure motors run smoothly and efficiently. Stay tuned. So, how do engineers handle these effects of armature reaction, you may wonder? It's a great question, and the answer lies in the meticulous design and creative problem-solving of motor engineers. One of the primary techniques used to manage armature reaction is the incorporation of compensating windings. These are additional windings inserted in the motor, typically in slots cut into the stator poles. As the name suggests, compensating windings are designed to compensate for the magnetic field created by the armature current. They carry a current in the opposite direction to the armature current, effectively creating an opposing magnetic field. This clever counterbalance works to neutralize the effects of armature reaction, maintaining the integrity of the main magnetic field. But that's not all. Engineers also adjust the design of the magnetic circuit to further mitigate the effects of armature reaction. They can alter the shape and positioning of the stator and rotor poles to ensure a more symmetrical magnetic field. This way, even if the armature reaction distorts the magnetic field, the motor's overall operation remains unaffected. In essence, managing armature reaction is like conducting a delicate symphony of magnetic fields. It requires a deep understanding of electromagnetism and a deft touch in engineering design. Engineers employ these techniques to ensure the motor operates efficiently despite the challenges posed by armature reaction. In summary, armature reaction plays a crucial role in the operation of an electric motor. It's the interaction of the magnetic field created by the armature current with the main magnetic field of the motor. The effects can be demagnetization or distortion of the magnetic field. But fear not, engineers have got this under control. They design motors with techniques like compensating windings to mitigate these effects. Understanding and managing armature reaction is key to designing efficient and effective electric motors. Keep wondering, keep learning.